Angie.
I'm Ashley. I'm Michelle.
And I'm Russell.
And today we're doing a Draw My Elements Group 5A through 8A. Group 5A consists of elements nitrogen, phosphorus, arsenic, antimony, and bismuth. Group 5A has an electron configuration of ns2np3. Antimony and bismuth are both metallic and lose electrons to form cations. They both cannot form ionic compounds. In group 5A, there is nitrogen. Nitrogen has a very strong triple bond, which will result in bonds being very unreactive and a release of large quantity of energy as heat. Nitrogen also has an oxidation state of +1 or +5.
Nitrogen continued. Example, decomposition reaction of NH4NO2. NH4NO2 solid produces with heat N2 grams plus 2H2O grams. 1.0 grams of NH4NO2 times 1 mole of NH4NO2 all over 64.05 grams of NH4NO2 equals 1.56 times 10 to the negative 2 power mole NH4NO2. Use this to calculate the volume of N2 from the ideal gas law. We will now use the formula PV equals nRT. From this, we will divide P on both sides, and it will become V equals nRT over P equals 1.56 times 10 to the negative 2 mole times 0.08206 times liter L to ATM all over K times ATM times 523K all over 1 ATM, and this gives us the volume of 0.670.
In group 5A, there's also phosphorus, which has a greater electron negativity than nitrogen. Phosphorus also has a larger atom than nitrogen. There are different forms of phosphorus. For example, white phosphorus, which is very reactive and it reacts with air and produces combustion. Black phosphorus, which is less reactive and it's a regular cylinder structure. And red phosphorus, which consists of chains, and it is created by heating white phosphorus.
Moving on to Group 6A elements. Group 6A consists of oxygen, sulfur, selenium, tellurium, and polonium. Group 6A elements need 2 electrons to make a noble gas, and they also form covalent bonds with other nonmetals.
The chemistry of oxygen. The most abundant element in and near the Earth's crust. Ozone, which is O3, is made by pressure and electric charge through pure oxygen. O3 is also less stable, and it disrupts the bond in O2 to give oxygen atom. And now we will look at the chemistry of sulfur. Sulfur oxides are elemental forms which are called rhombic and monadinic sulfur. Both contain S2 molecules, and the most important oxides are SO2 and SO3. Now group 7A elements, which consist of fluorine, chlorine, bromine, iodine, and astatine. All 5 of these elements are known as the halogens, and the electron configuration is ns2np5. They are all nonmetals with high reactivities and high electronegativities. Halogens form polar bonds with other nonmetals, and they also form ionic bonds with metals in lower oxidation states.
7A continued. Hydrogen halide can be represented by the chemical formula hydrogen gas plus elemental gas yields 2HX gas. Hydrogen halide dissolves in water and behaves as an acid. Oxyacids of halogens become stronger as oxygen atoms are present. 7A continued. Adding 2 halogens together produces an interhalogen compound. These produce orbitals at 1, 3, 5, or 7. For example, ClF3. This compound has an unshared electron pair.
Moving on to group 8A elements, the noble gases, also known as monatomic gases, which are filled with s and p valence orbitals, making these elements very unreactive. Heavier elements form compounds with electronegative elements, for example, fluorine and oxygen. By the way, the group 8A elements consist of helium, neon, argon, krypton, xenon, and radon. Helium has an electron configuration of -2s2, and the rest have an electron configuration of ns2 and p6.
Thank you for watching our video!